The topic of the panel is cloud is starting to think, and we have some amazing panelists today with one of the moderator as Kunal Kushwaha.
If you add a lot of agents to any system, you mentioned the complexity around it. Is it true that the system is more likely to fail because we see in industry a lot of AI projects don't even make it past? The failure rate is quite high. Why do you think that is? And how do you keep the cloud simple and reliable even as we add more brains to it?
That's a good question. So I would agree with you. Adding more AI agents could actually make your system complex. So it's not about you adding too many AI agents. You should add AI agents based on what they want to do. So you should define roles. A particular AI agent, for example, could be just for cost monitoring, just for security. And so you should define policies. You should define guardrails. Defining, or you should actually treat your AI agents like microservices, and not have too many AI agents just for a single task. So when you do that, you would know what a particular AI agent would be doing, and then you can observe it to actually troubleshoot whenever there's an issue. So I could agree with you
So
adding.
how do you pick if there are multiple, let's say if I say models for a specific task, how do you pick the best one? Or is there like how do you pick one?
So in my day-to-day use cases, I would prefer ChatGPT for very generic or very simple generic questions. If I'm working on programming stuff, I would prefer Claude
Hmm.
uh, or Cursor. So depending on the use case, I mean, when you get hold of it, you will know which AI would work for a particular use case, or which one would you use for coding, which one would you use for troubleshooting and stuff like that.
I would like to add a point on that. Just like you said, people are using AI agents a lot these days in their workflows, and adding more complexity is inversely proportional to making it more reliable, right? So, when you add so many AI agents, I think there has to be isolated boundaries as to what each AI agent is doing. I have been part of teams in companies where there is so much confusion because the team is using three AI agents and all the three AI agents are doing the same job, that is tracking metrics. Now there has to be separated boundaries at that place, because when you add complex agents, deploy it in your cluster or whatsoever, you are basically making handling this thing more complex. So you're doing the opposite job of what AI was supposed to do. And that's where you have to, draw a very hard boundary as to what you are deploying and what you want to manage. And for that respect, I think I have an idea of why don't we have an AI agent that does the job of a scrum master, like basically sees what AI agents are deployed and what are just increasing complexities, and basically reduce those types of dependencies on AI agents. So that's a way we have to shift our thinking from just giving instructions to AI to actually deciding what is the intent of that AI tool. That's a very important shift that our generation really need to think about when using such tools.
Yeah, and just to add upon this, so it all basically begins when you start to define what your agent will do, right? So that starts with the architecture of the agent. So maybe when you also think from the cost perspective, you will probably have a planning agent that will be a agent that will have, or an LLM that will have a larger context window. It'll be like a 20 billion parameter model that you can use to do the planning. But then you have these specialized sub agents, what Nasi also mentioned, in terms of being able to execute these tasks. And the way that you have to think about this is that as long as you can get those deterministic flows up and running and let the agents actually handle those, but the tasks where you don't have those deterministic flows possible, maybe it's already deployed your agents in production and you have a lot of edge cases which you might not be able to actually train the agent on. In those cases, have the human in the loop, and as the other folks have also mentioned, have proper guardrails set in for those particular scenarios so that you can always keep an audit trail of what are the actions made by the agents, what was the human that actually invoked that particular agent, and what was the end response. So it's a combination of having to mix and match this capability of how the agent architecture basically looks like, and ultimately having proper guardrails, as other folks have also mentioned, which is equally important.
Yeah, there was a leaked memo from Google board that people won't pay for proprietary models if they get similar performance from open. So I do think proprietary models are way far ahead. But if I'm getting my work done with open source models, then I won't really pay, you know. which is an interesting shift that I have seen. Cool. We want to talk about cost a little bit because it can get quite expensive, and the usage is always variable, you know. So, what are some of your best strategies to plan around the budgeting so that um, you don't break the bank?
Yeah, so I can probably start.
Yeah.
So I had the opportunity to work on an end-to-end AI gateway platform. So for folks who are not aware of the term AI gateway, it basically comes from the term API gateway. A lot of you must have heard of open source projects like Kong or HA Proxy. These have always been there. If you're building microservices-based architecture, they will help you with load balancing, having some level of RBAC and observability. So when you have a shift from API gateway to an AI gateway, what are the new components that you add? So you add much more fine-grained RBAC control for your LLMs and for agents. You have observability where you're now also keeping a track of total number of token consumption, both for the input tokens and the output tokens being generated from the LLMs, and have much more fine-grained, again, authority over what were the audit trails for the agents and the logs that you're maintaining, right? So you have a few more building blocks on top of your traditional API gateway architecture that you see now in AI gateway. And naturally, also a lot of the open source API gateways today are now calling themselves AI gateway, including Kong. So I had this opportunity of being able to actually work on this entire platform at my previous company, where we built this entire end-to-end platform, and then we also actually self-hosted LLMs. So we built this entire capabilities to be able to host LLMs right next to your database. So this capability, of course, it came with a lot of scrutiny in terms of how we are deploying our applications and how this AI gateway comes in, right? So there are three things. One is I spoke about how you can efficiently decide how your agent architecture actually looks like. So you don't have to use a larger model for running smaller tasks. So you do the planning with the larger model, and you let the specialized sub models or sub agents use smaller models that have enough context and they can do really well. So SLMs can do tasks, they're not generalists, but they do one task really well. And that saves you a ton of cost. Second is, as you've adopted an AI gateway, you can keep track of your total metrics that you're using. You can set guardrails in terms of how much maximum consumption you want, right? And in case it goes beyond that consumption, just shut it down. And third is, once you have properly planned your context for your overall system and keeping track of, okay, like, are you overpopulating the context of your agents? Again, that can lead to inefficiency in terms of how your LLMs basically perform. So all of these are standard techniques that will help you to overall maintain your cost when it comes to the FinOps side of things for agents. So maybe other folks can also add in.
Go ahead with adding a bit up to this because I was working on a project very closely, which came down directly to cost optimization of Kubernetes clusters. And for that, I was using this open source project called OpenCost that lets you see what the AI infrastructure is and decide how much it is costing us to actually maintain it and all the things are on top of it. So that's where I came across two projects which are doing this job really well. They are not graduated yet, but they are still in beta, and a lot of companies are still using it. I know personally a lot of my clients were using it. So on those grounds, there is AI Bricks, and then there is NVIDIA Triton, which basically works on top of AI infrastructure. And I think the endpoints that these types of project gives us is very important to track when it comes down to figuring out what would be the cost. So, like Shivai already mentioned, observability gives us a huge hand on top of how much like by tracking the metrics, the alerts, and all the logs and traces, everything, we will be able to figure out how much we are like taking the space in terms of AI usage. And it's very important to have our own alert system set it up. I think we can even have an AI that itself judges how much we are using AI. So it's very important to have such monitoring done on top of using AI. And I have recently started seeing teams even do this, that they have started building their own in-house AI platform, so
Yeah.
that the data is not going out and the cost is also reduced.
Do you think that is like a permanent shift or is just like a temporary reaction to high bills?
I think it's temporary but it can be a permanent shift. I don't want to be opinionated about it, but I think it's a big thing to do in house because it's in itself a different challenge that teams has to face. But we would love to see what happens.
I want to add on the cost part. Since Shiva mentioned about the architecture thing, obviously you should know which, if you want to use an LLM or an SLM, depending on the task or on the context window, that would help you obviously save cost. Another thing would be to set a budget. Just like you set a cloud budget, you can set a budget so that your team could experiment with different models and see what is right for you rather than spending too much credits or too much money on the AI. Uh, Lastly, observability 100% is important for you to track how much you're spending, set up metrics, set up notifications on Slack or whatever communication channels you might be using. These three things, architecture, budgets, and observability could help you save cost.
So in your day-to-day life, in when you work with Kubernetes, have you started seeing the trend, and how are you implementing AI to make your infrastructure smarter?
I can start with this. So I remember when MCP came into picture, and I was very interested into it. And I first of all I went into VS Code and installed MCP servers, and I was very it was like magic for me to just put a prompt saying create a EKS cluster for me with this nodes, and it actually created it. So I have been using it MCP since then. So I think I every day I use MCP or AI stuff like this for my day-to-day task.
Shive?
You know, speaking about MCP servers, so there is speaking about MCP servers, there is a project from Rohit, who is also one of the speakers. His project also got incubated into the CNCF. It's called the K8s MCP. Is like has over 700 different tools. You can have tools related to your main kubectl commands, and then you can also have telemetry data coming in from OpenTelemetry. So there's so many integrations. And apart from this, from this K8s MCP, I think the other aspect of this is that within Kubernetes itself, there are a lot of other projects like KAgent or KMCP that allows you to get a more granular details on what's actually happening, and now you can deploy agents more efficiently on Kubernetes. But the other aspect of this that I really love is when you're able to apply your principles of agents to also automatically do RCA, right? So there are so many startups that have now come up that will do that for you. There are also projects that are doing LLmetry where you're I mean, gradually you're getting logs around how the LLMs are actually working, and you're getting proper traces. So OpenTelemetry has its own uh, spin-off for LLmetry, which allows you to identify all of the logs. So I think that combined with your traditional architectural things that you are making within Kubernetes. So as I think as you mentioned that you're not just looking at as AI as some brand new thing. It's essentially following a lot of the principles of traditional microservices, right? You're using a lot of the different tools that are traditionally used for pure DevOps, and you're just now reapplying it with a few additional guardrails when it comes to AI. So effectively, we're not changing anything uh, with using our traditional architecture. You can still continue to use that. It's just a few more building blocks like MCPs that we have added to ensure that AI is able to help us with not only deployment but also on the side of observability, helping reduce the SRE's workload as well.
I want to add more thing. So on my day-to-day basic, I actually refer documentations for troubleshooting. And I don't know if you might have heard about kappa.ai. So let's say you work in Docker and you have some problem. You go to ChatGPT and you paste your error. It will not give you the right answer. Maybe it can give you a right answer, but right now, if you go to Docker Docs, and there's an option where you can ask an AI, and then if you paste your query to it, it will give you answer based on the data that is trained on Docker Docs itself. So this is the new trend that companies are using in their documentations. So rather than you going into ChatGPT and getting a general response, you can actually get an accurate answer because they are all they have their own rack solutions. They are trained on their own data. So I think that's one of the thing that I use a lot.
Yeah, we were talking about platform engineering earlier. My question is, how do you see the role of a platform engineer evolving as the cloud begins to handle more of the maintenance and resource optimization? How many platform engineers in the audience? Very okay, decent.
I'll go ahead and add to that part. So I think I have seen a very interesting shift in platform engineering. Speaking of, earlier, the platform engineering as a field was very reactive. What I mean by reactive is that you see that something like an outlier or some incident happened, and then the platform engineers get in place to fix it. This is something very reactive. Now, ever since AI has came into existence, I am able to see something which is much more proactive than earlier. Alerting system was there, metrics were there, they were traced and everything. But by proactive, I mean AI is able to look at these metrics 24/7 without somebody in from human, like some human having to interact with the metrics all the time, take a look at it and all the time. And AI is proactively being able to take decisions. So the whole shift is from reactive to proactive, which is a very interesting thing that I am seeing in platform engineering these days. And it can be really used at the benefits of the company to make it more scalable, the project more scalable, much less incident than ever before. So things are going at a very good pace is my point on this.
Uh, to add on that, I mean, one of the most important problems these days is observability. It's very important. It's very difficult for you to understand what is the root cause or what is causing a problem. And these days, AI help us.
Why is that?
I mean, people are confused. They don't know what systems are placed where. They don't know how things work. They don't have complete knowledge.
Hmm.
So AI helps you and they notify you before the actual things happens, and then it can save you money. It can save your business. So that thing that's one of the biggest things that AI is helping platform engineers to solve.
And just to talk more about the shift, right? So traditionally, if the platform engineers were kind of relying on, okay, what kind of infrastructure choices I need to make, what is the observability choices that I need to make, as Paika mentioned, it is very reactive. But if you look at one of the drawbacks that we still have today, and the reason why platform engineers have still been a bit precarious. So just to give you one instance, I was at KubeCon last year, and Solo had this booth around K-Agent, and they had about 10 different laptops on or stations where you can give and try on their K-Agent platform, because they were the ones who released this open source project. So I tried to go through this lab of KMCP where the idea was that the K-Agent was trying to run kubectl commands, and on 3 different tries it basically failed, and that is mainly because it was starting to hallucinate on what type of namespaces and pods are actually there in the cluster. And that is one of the inherent problems that we will still find. So we are still not there at a stage where we can confidently deploy full-fledged or fully autonomous systems inside of production environments. Yes, for example, in my previous company, we were using it for our staging environments and our dev environments, but we were clearly not comfortable of being able to deploy them in production. So depending on how complex your workload is or how complex the business problem that you're trying to solve, you may or may not want to just completely ship a fully autonomous platform engineering powered by AI. Because the key aspect here is that basically the AI systems today lack the overall business knowledge, right? So they will be very good at being able to do observability, understand the logs, or being able to automatically provision your replica sets or infrastructure as well. But how do you marry together the decision that they're making on an operational level and also be able to do the business justification? And that's where I feel the role of the platform engineers in this react or in this proactive endeavor would basically come together. They will need to be a lot more well versed with the business needs and the decisions that are being made by the higher ups in their company, and understand how those platforms are being built very closely correlated to these business needs. So
Hmm.
when they are designing systems, they might use AI to help do some of those particular actions, but they always will have to make a proactive decision making on how the AI is making decisions and whether those are well set with the business goals of the company, right? So, for example, cost, right? Cost is also one of the key aspects of the decision making within the company. So I think you have to be more precarious in terms of how the agents are making the decisions, because we are still not at a place where we can make 100% autonomous decision. So you have to be aware of what the agents are doing. So you have to wear that hat of what software engineers are today doing, right? Like you're using Cloud Code or you're using open code if you're open source. You still do ensure that all of the code changes that are being made are those do they make sense? Because a
Hmm.
lot of these coding agents don't have knowledge of the business requirements of the company, right? Or not to a extent where they can make 100%, you can ship 100% code. it's still this shift of 80% writing code with AI and 20% reviewing the code. So similarly, you can think of platform engineers, even if you're having 80% of this automated by AI.
Now Claude supports code review.
Yeah. But again, it's very expensive, right?
Yeah.
But I would say that Claude Code still doesn't have complete access to all of the business decisions that you're making.
Yeah.
So systems are being made where you're marrying together the context of the code and business as well, but it's still not reached to a stage where I don't even know like one single company that probably might be doing that
Cool.
100% end to end.
So one question is like, how do you, if AI agents are handling a quarter of work or most of it, and we are reviewing code, but then there needs to be someone responsible if the AI agent does something that is not right. So how do you make sure that your engineers are not losing out on those skills so that they can manually fix things when it goes a different way?
I could say something on it, but recently I read a blog from Meta where they have been advised that the interns or junior engineers are not supposed to push code if they are making it through AI. A senior engineer has to review it before they actually push it. So first of all, engineers should know what they're doing and obviously review the code before they actually push it. So companies are getting mature slowly, and I think this would be a norm coming forward. This would be very common. People will people will adopt this, and they will get to know what are common issues or what are common errors that happens, and then they will start transferring knowledge to other teammates and maybe probably solve it.
Okay, I'll add to this. So, how do I think about it? So, when I started like early in my career, as a junior engineer itself, I had access to AI. It's as simple as that. And a lot of junior engineers are shouting about, okay, we have AI. How would we even build? Because we were never put into that cognitive tension onto our head that we have to think. Because we always had AI from the first year for college. So, at that point, you have to think of it this way, that seniority, right? When does someone become from a junior engineer to a senior engineer? It's not about the number of years they have spent in the industry, or it's not about, the title itself. It is about how many patterns have they gone through before they were at the place that they are. So a senior engineer has to understand a lot of patterns, and throughout their experience and the number of years they have spent in the industry, they become familiar
Just
with a
takes
lot of
few
these
questions and
patterns.
wrap.
Now,
Five-
as a
5 minutes.
junior engineer, what?
No, it's all good.
Okay.
My mic
So
is on.
as a junior engineer, the benefit we have right now is that we don't have to wait for these many years to get accustomed to these patterns. We have AI for the same. And that's where I would answer the question, that right now the what was the question again? Sorry, I just
Yeah, how do you make sure that people don't lose out on the skills?
Yes, exactly. So the whole point is that you have to make yourself develop that intention or that intuition about how you are using AI for pattern recognition. You need to understand the intent behind using AI. Now, there is a very interesting thing. People use AI and they think that they will be able to build any application out there, and oh God, everyone can be Sundar Pichai or anyone can be Sam Altman. That's not the truth. It was never about the product. It was always about building the application. It was not. It was about selling it. It was about retention of users. It was all about those things, right? So that's where I say AI has speeded up the thing, but intention is still with the human. It's not with AI. You need to have clear intention about why you are using it. And when it comes down to keeping the skill alive, it is about when AI is giving you the code, you need to know what it is doing. If you don't know that, if you don't know the intent behind the code written by AI, you will not be able to scale it at a level or sell it at a level which all the engineers and successful product people are doing these days. So I think the intention has to stay alive, and you need to understand the patterns. And on that note, I really think AI, you have to keep your cognitive ability alive by thinking more with AI. That was the point.
Yeah, I mean, not much to add there, but the basic rule of thumb is that stick to your fundamentals because those will still be helpful when you are architecting bigger applications and you're reviewing code from AI.
Let's take some questions and then we can wrap up any questions. Yes.
Mike.
So maybe if I understand the question, and probably just for repetition, when you talk about the human in the loop, if the AI is giving us a lot of content or responses, how do we understand which one should be taken and probably ignore, right? So I think ultimately what I foresee is coming back to this point of the business goals, right? So when I like to architect my agents, I always like to see what are the areas where I definitely need a human to provide their input in terms of the output given by the AI. If it is very business critical tasks, if there is a greater level of autonomy required, where you have a greater chance of the AI hallucinating, those are the areas where I would like to keep the human in the loop check. But for the parts of the project which are fairly deterministic in nature, those will be the ones where I don't even care. Like I'll let the AI run its course, and that you'll be able to find that or identify what are the parts where you need that granular control over what the output is, right? So ultimately, it depends from company to company. Some companies are more risk averse. They'll say like, I'll just run the AI in YOLO mode and I'll not care about what happens, right? But other companies will probably be very precarious, very precautious. They'll take precautious measures when it comes to running the AI. So, maybe they are at a greater risk of supply chain security attacks. So they want to understand what are the, like, even if there's a code being generated from AI. So in my previous company, I was using Docker to be able to actually run, so Docker with Node.js. So for example, if there's a bunch of Node.js code being generated from the AI, I would run that inside of the Docker container and execute it. And the output, then if there is like a file, it'll be scanned. And then if the file is fine, only then I would basically have an external storage, or the volume to be able to then use that file. So these are the decisions that you have to make based on your security level or concerns, or the business decisions that you have to make, how important those are for your customers, and based on that I'll define my architecture.
Yeah, I would add just one point to it, that you need to understand how to question the AI when you get the output. That's literally everything. You don't have to code from scratch anymore. That's not the problem statement. The problem statement is you have to work with AI, and by working with AI, we mean that you need to understand how do you question the output that AI has given you and how much you understand it. Because AI will give you 40 lines of code for the same response, but you need to understand that it does not need 40 lines. It needs only 4 lines. You are wrong. So that ability has to still be there, and that's how you'll be able to decide.
I mean, yeah, that's right. So if you understand the human and the AI interaction, humans should be setting up that guardrails. AI should be doing the automation. So that's how it should be. You should know what what the AI is doing, and then the AI should handle the automation part. If there's any issue, you should just change the policies or guardrails for it.
Amazing. Well, thank you, panelists, and thanks. So the question will be here, whether it's email, so you can ask questions, and you can also connect with us on socials. And yeah, this was great. Thanks for joining.
Thank you.
Thank you.